A very good morning, ma'am. My name is M. Varshasri and I'm from Computer Science Engineering branch and my roll number is 234G1A33I1 and today I'm here to give a PowerPoint presentation for the CAA2 assignment on the topic of verify Taylor's theorem with the Lagrange's form of remainder for the subject linear algebra and calculus, and the subject code is 23M8001. My topic today to give the presentation is verify Taylor's theorem for f of x is equals to 1 minus x whole power of 5 by 2 with Lagrange's form of remainder up to 2 terms 0, 1. The Taylor's theorem statement: if f maps a, b belongs to R such that f power of n minus 1 is continuous in closed bracket a, b and f power of n minus 1 is derivable in the open brackets a, b, or f of 1 exists on a, b and the p belongs to Z plus, then there exists a point C which belongs to open brackets a, b such that f of b is equals to f of a plus b minus a by 1 factorial into f dash of a plus b minus a whole square by 2 factorial into f double dash of a plus b minus a whole cube by 3 factorial into f triple dash of a plus and so on up to b minus a whole power of n minus 1 by n minus 1 factorial into f power of n minus 1 into a plus Rn, where Rn is equals to b minus a whole power of p into b minus c power of n minus p into f power of n into c by n minus 1 factorial. In the question, they given that f of x is equals to 1 minus x whole power of 5 by 2 in 0, 1. As based on the Taylor's theorem, f of x, f double dash of x are continuous in closed brackets 0, 1 and f double dash of x is derivable in open brackets 0, 1. Thus, f of x satisfies the conditions of the Taylor's theorem. We consider the Taylor's theorem with Lagrange's form of remainder, that is f of x is equals to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of theta x with 0 less than theta less than 1, which is considered as the equation 1. Here a is equals to 0 and x is equals to 1, where f of x, that is in the given question they gave that f of x is equals to 1 minus x whole power of 5 by 2, where f of 0 that is equals to 1 minus 0 whole power of 5 by 2, that is 1 power of 5 by 2. Finally f of 0 is equals to 1, and then when we differentiate f of x we get the f dash of x by using a formula d by dx of x power n, that is equals to n into x power of n minus 1. By using the formula we get the f dash of x is equals to minus 5 by 2 into 1 minus x whole power of 3 by 2. Then f dash of 0 is equals to minus 5 by 2 into 1 minus 0 whole power of 3 by 2, that is minus 5 by 2 into 1 power 3 by 2. 1 power 3 by 2 is 1. 1 into minus 5 by 2 minus 5 by 2, that is the value for the f dash of 0. Then we do f double dash of x. When we differentiate the f dash of x we get the f double dash of x, that is 15 by 4 into 1 minus x whole power 1 by 2. The f double dash of 0 is equals to 15 by 4 into 1 minus 0. We put the x is equals to 0 and then we get 15 by 4 into 1 into whole power 1 by 2. That is the values of f double dash of 0 is equals to 15 by 4. Here we got f of 0 is equal to 1, f dash of 0 equal to minus 5 by 2, f double dash of 0 equal to 15 by 4. From the equation 1, f of x is equals to 1 minus 5 by 2 plus x square by 2 into f double dash of theta x. The equation came from substituting the values that we derived, where f double dash of theta x is equals to 15 by 4 into 1 minus theta x whole power of 1 by 2. Here x is equals to 1. By substituting the value x, we get f double dash of theta x is equals to 15 by 4 into 1 minus theta whole power 1 by 2. 1 minus x whole power 5 by 2 is equals to 1 minus 5 by 2 plus x square by 2 into 15 by 4 into 1 minus theta whole power of 1 by 2. Since x is equals to 1, we get 1 0 is equals to 1 minus 5 by 2 plus 1 by 2 into 15 by 4 into 1 minus theta whole power 1 by 2. As 1 minus 1 equals to 0, we get the above equation. Then 0 equals to 1 minus 5 by 2 plus 15 by 8 into 1 minus theta whole power 1 by 2. 0 equal to 1 minus 5 by 2, we get the minus 3 by 2 plus 15 by 8 into 1 minus theta whole power 1 by 2. Then if we send this minus 3 by 2 equal to the RHS side, then we get the 15 by 8 into 1 minus theta whole power 1 by 2 equals to 3 by 2. If we send this 15 by 8 into the RHS side, then it becomes the reciprocal, that is 18 by 50, 8 by 15. 1 minus theta whole power 1 by 2 equal to 3 by 2 into which becomes reciprocal as 8 by 15, and then we get the final answer as 1 minus theta 1 by whole power 1 by 2 equals to 4 by 5. 1 minus theta whole power 1 by 2 equals to 4 by 5. By doing the squaring on both sides, we get the 1 minus theta whole power 1 by 2 whole square, where the power 2 and square 2 cancels, and the 4 by 5 whole square. 4 square is 16, 5 square is the 25. Then we get the 1 minus theta equals to 16 by 25. If we send this 1 to that side, then we get the 1 minus 16 by 25. Then theta is equals to 9 by 25, where the 9 by 25 value is 0.36. That means the theta is equals to 0.36, which belongs to 0 comma 1. Thank you for giving this opportunity to give a presentation on the